For the talk, the title is a little partial. To be exact, I will present you a new formalization of real number on the proof assistant chart, which use univalent foundations. To begin, I will use formal proofs to formalize my new real numbers, and the formal proof is a mathematical proof written using a simple language, enough precise to be checked by a computer. And to do these formal proofs, we use a proof assistant, which allow to write and verify formal proofs. There is several proof assistants. Here you have a list of proof assistants where there is real numbers. All formalizations are different because they are based on difference on various properties, logic, and other. The advantage is that when we do a proof, the result is guaranteed. But the process may be tedious, and one of my goals is to do user-friendly libraries, and not only for specialists. And as said in my title, I will work in the proof assistant church. Now, my goal here this year will be to define real numbers. Then the definition of the sets of the real numbers is a non-trivial abelian field, totally ordered, Archimedean, and complete. There is various ways to define, to formalize real numbers. And in proof assistance, we can find axiomatic real numbers. Axiomatic when we only set all the properties and use this. Or we can use constructive real numbers. Then we will build a set of numbers which satisfy all these properties. To return to the church proof assistant, there is also in the standard library an axiomatization of real numbers, and then build constructive real numbers. And there is also a library named Seacorn with real numbers built using Cauchy sequences. And now I will focus on the Dedekind cuts. The libraries existing in Cauchy are various properties. For the library from the standard library, which name reals, as I said, there is axioms. Using adding the library I built during my PhD, the library Cauchy, we have a user-friendly library for analysis for total functions, and but all the axioms can't be implemented. For example, we can't build a set where we can decide if two numbers are equal or not, but it is one of the axioms of this library. And then one of characteristics of Cauchy is when we have a proof, we can extract a program if all axioms are are implemented, we can extract a program, and with this library, it cannot be done. The other library, Ccorn, it's constructive. We have cloche sequences. We have a good property of analysis with total function for total and partial functions, but it is really not easy to use this library. It can only be used by specialists, and then it is not interested. And for this year, my goal will be to build a new library based on the Dedekind cuts. What is the Dedekind cuts? If we have, if we look at all the rational numbers, the Dedekind cuts is when we cut these rational numbers in two intervals, which some properties, and the real numbers is the whole between these two sets. In mathematics, we can express this property like this. The advantage of this definition is that it is a nice definition, really clear, but there is difficulties to implement it because there is lots of hypotheses, and moreover, the set U can be defined using only the set L. Then in formal proofs, in proof assistant, when there is the Dedekind cuts, we used to only define the set L. We have less actions, less properties to define it, and then it is easier to define. But we have difficulties to define operations, in particular the multiplication, because you have to separate different cases if the number is positive or negative. And another definition is to consider the interval, but only on non-negative real numbers. And this allows to define non-negative real numbers, and all the real numbers are defined using a pair of non-negative real numbers and using an equivalence. And now it is easier to define. We have good definitions for operations. By example, for the sum of two positive real numbers, it is the set of all the sums in the set of all the sums. And the problem now is how define quotient in Coq. There is an implementation of setoids in Coq, but it is not useful and really slow to compute. And then in the standard Coq, this definition is not easy to formalize, to use. But I will work this year on the library Unimat, which aim to form excuse me. It's a new library where we use different properties than the basic Coq. It is an extension of Coq, and using the univalent foundations, we have more tools to build things which are impossible or really hard to formalize in touch. And then for my work, for the formalization of real numbers, this library will be, for me, a new board with new properties, various, and I will also, as I will work with conceptors, we will build a better library together. Then for this year, my project will be to build real numbers, and after formalize a library of real analysis as useful as possible. Thank you.